So in today's lesson, we're going to talk about 0.8 systems of linear equations. What we are going to try to do is we're going to try to take two equations and basically find a point of intersection, find a point that they have in common. So upon completion of today's notes, you should be able to use the graph or solve these using graphing, substitution, and elimination. So we're going to start with graphing. And graphing, what we are looking for is we're looking for point of intersection. So we're trying to see if this has no solution, if it has one solution, or if it has infinitely many solutions. So when I'm going to graph these, what I need to do is I need to make sure that my equations are always in the form y equals mx plus b, because m is my slope and b is my y-intercept. And if I can get my equations in y equals mx plus b, then I'm able to graph them. So if we take a look at our first example here, you can tell that my first equation, y equals negative x plus 3, is of the form y equals mx plus b. So we start at my y-intercept, which is 0, 3. So I'm going to go ahead and put that on the graph. So I got that point there, 0, 3. And then we have a slope of negative 1. So I'm going to go down 1. And if you remember from last year, we always run to the right. So we go down 1 to the right 1. My second point is 1, 2. And then I'm going to make you do a third point. Third point to make sure we have a straight line. Down 1 to the right 1 because of it is negative. And that is 0.2, 1. So then you will draw your straight line through those 3 points. And I'm going to call that L1. That is line 1. That is this one highlighted in green. Now we are going to take a look at equation 2. And in equation 2, which I'm going to highlight right here, we're going to call this line L2. We call this line L2. Again, it's of the form y equals mx plus b, and it allows me to go ahead and graph given my information. I know my y-intercept, which is negative 3. I also know my slope, which is a positive 2. So my y-intercept is negative 3. So I'm going to graph 0, negative 3. 0, negative 3. And that is my first point. Now I have a slope of 2 over 1. So I'm going to go up 2 this time because it's positive, and to the right 1. And so my second point is at 1, negative 1. And then again, we're going to go up 2 and to the right 1. And what you'll notice is we're sharing a point right here at 2, 1. So my graph, when you draw your straight line, intersects at 2, negative 1. Right here at 2, negative 1 is my point of intersection. So I have one solution. And that one solution is that point of intersection, which we call 2, 1. So now we're going to take the same ideas and we're going to apply it to B. So B this time, okay, we have line 1 as the top one, and then line 2 as the bottom one. What you will notice in both of these is neither one is in the form y equals mx plus b. Remember, I want them to be y equals mx plus b, so that way I can tell where my y-intercept is and where my slope is. So in L1, I have y minus 2x is equal to 6. And I want to get y on its side by itself, so it's just like solving a linear equation, which we've worked on earlier this week. We're going to add 2x on both sides. My 2x's cancel on the left, and I'm left with y is equal to 2x plus 6. And again, this is line 1. So now we have information here in line 1 that we are able to graph. Okay, so my y-intercept is at 0, 6, which is off of the axis, and this is why I make you label your points. So that is 0, 6, so I can know what that point is up top. Now my slope is positive, so I need to go up 2 and over 1. But my graph doesn't go that far, so what I'm going to do is I'm going to go down 2, so down to 5, down to 4, and then over 1. And so what you're going to be able to do, this point is called -1, 4. What you are able to tell is that we had the same kind of slope from this point here in yellow to that point in yellow. So if you take it and you flip it and you go in the opposite direction, we went down 2 and to the left, it gives you that second point. And I got to do it again, so I'm going to go down 2 and to the left because I'm out of space going up top. And that point right there is -2, 2. Now that is just the line of equation 1. So that is L1. Now we need to find L2. So in L2, in line L2, we have 3y minus 6x is equal to 9. And I want to isolate that y. I want to get it on its side by itself. So I'm going to add 6x to both sides. Whatever you do to the left side, you must also do to the right side. The left side, they cancel, leaving me with a 3y is equal to 6x plus 9. Now I'm still not done because I need y to be by itself before I can graph it. So I'm going to divide everything by 3. On the left side, my 3's cancel. I'm left with y is equal to, and then I have 6 divided by 3, which is 2x. 9 divided by 3, which is 3. So now in L2, I do have an equation that I can graph. My y-intercept is at 0, 3. So it crosses the y-axis right here at 0, 3. Let me change to a lighter color so it's easier to see. We'll go green. So 0, 3, that is where that point is at. So that is 0, 3. And then my slope is 2. 2 over 1. So I'm going to go up 2 to 5 and then over 1. So that point right there is at 1, 5. Now again, I ran out of space going up. The graph was not big enough, so we're going to go down 2 and to the right 1. And that point right there is -1, 1. Okay. Now that I have 3 points, I can draw my straight line. As you can tell from this picture, my lines will never touch. Okay, my lines will never touch. So this is NS. There is no solution on this problem. Our lines will never touch and will never intersect. This is a no solution problem. Now we're going to do an example of substitution. Substitution is just the way it sounds. We're going to take one equation, we're going to substitute it into the other. So I'm going to take this 4x, -4x, and I'm going to plug it in for y into my second equation. So I got y equals -4x. I'm going to plug it into my second equation. So I have 2 times -4x plus 3x is equal to 8. We're going to simplify. We have 2 times -4x gives me a -8x plus 3x is equal to 8. Still, we are working to solve for x. -8x plus 3x is -5x is equal to 8. And then we're going to divide both sides by a -5. My -5's cancel on the left side, and I get x is equal to -8 over 5. So that is my x value. Once you know your x value, you are going to take your x value and you're going to plug it back into one of the original equations. I think that using the top equation is the easiest because it's just y equals -4x. So we use y equals -4x, and we are going to plug in -8 over 5. So y is equal to -4 times -8 over 5. And now we're just going to simplify. Take the top times the top, your denominator by your denominator. So this is the same thing as -4 over 1. And y is equal to 32 over 5. So now what we have is we have an answer for x. We have an answer for y. We know the point of intersection. Point of intersection is always x comma y. And so my answer is -8/5 comma 32/5. That is my point of intersection of these two systems of equations. So then finally, we're going to talk about elimination. And in elimination, what you want to do is you want to eliminate a variable. Right? And so let's take a look at our variables. You can do it by getting rid of the x's or getting rid of the y's. I'm going to try to get rid of my x's right here. So I have 3x and 4x. So I got to find the LCD. The LCD of 3x and 4x is 12. So what do I have to multiply the top equation by to get 12? Well, that answer is 4. So I multiply the top equation by 4. When I multiply the top equation by 4, I get 12x plus 20x is equal to 28. Now I want to make sure that I get a negative number when I take a look at the second equation. When I multiply here, I need a negative x, so my x's will cancel. So to get to 12, I have to multiply by 3, but I want to have a negative x value, so it has to be -3. -3 times 4x is -12x. -3 times 2x is -6y, and that is equal to 0. So now that I have them in two, I have 12x and -12x. You add your two equations together. When you add your two equations together, your x's will cancel, and what you are left with is 14y is equal to 28. We are trying to isolate for y, so we divide both sides by 14, and we get y is equal to 2. Once you know what your y value is, you are going to take it and you're going to plug it back into one of the original equations. So we're going to plug it into the top one. So I have 3x plus 5 times 2 is equal to 7. 5 times 2 gives you 10. So I have 3x plus 10 is equal to 7. I want to isolate my x, so I subtract 10 from both sides. I get 3x is equal to -3. And then I'm going to divide both sides by 3, and I get x is equal to -1. Now I have my x value and my y value. I know my point of intersection, and that is going to be at -1, 2, and that is your answer.